Okay, hi guys. So in this lecture, we'll be discussing on nuclear fusion. So let's get started. So when two nuclei fuse together and form a relatively heavy nuclei, this process is known as nuclear fusion. Simple definition. So two nuclei fuse together and form relatively heavy nuclei. Okay. So we have one H2 fusing together with another one H2 and forming two helium-4. Similarly, again one H2 attaching with one H3 or fusing with one H3 form two helium-4 plus a neutron. So this is nuclear fusion. So very high temperature is required to initiate this process. To initiate this process, okay, and hydrogen bomb is actually based on the phenomena of nuclear fusion. Okay, next let us see Einstein's equation. Einstein's equation, so which is simply E equals to mc square, or one atomic mass unit is equals to 1.66 into 10 to the power minus 27 kg. Speed of light is 3 into 10 to the power 8 meter per second. So energy can be calculated, or rather energy of an atom can be calculated as 1.6 into 10 to the power minus 19 joule, or 1 electron volt is 1.6 into 10 to the power minus 19 joule. Okay, and 1 AMU. So this is not the energy of an atom. This is just unit of electron volt. So I'm now writing the energy of AMU. So 1 AMU is equivalent to 931.5 million electron volt, or simply 931.5 into 10 to the power 6 electron volt. Now in joule you can easily calculate by multiplying this term with 1.6 into 10 to the power minus 19 joule to get the energy of 1 AMU equivalent to, rather, to get the energy of 1 AMU. Now let's see mass defect. Or delta M. So we can write that in isotope formation, delta M is equals to mass of neutrons protons electrons minus actual mass of isotopes. This is N plus P plus E. Okay, so in nuclear reaction we can say that delta M is equals to mass of reactant minus mass of products. Okay. This was in isotope formation. This is in nuclear reaction. So reactants and products are in form of nuclei masses. So here reactants and products are in the form of nuclei masses. Or in form of rather okay, and the energy released in a nuclear reaction can then be said as delta M, which is the mass defect times c square. Okay, so let's now see binding energy. So binding energy is the energy required to break nucleus into its constituent nucleons. Energy required to break nucleus into its constituent nucleons is called binding energy. And when energy released when nucleus is formed from its constituent nucleons, so it in other way around, it can also be termed as or said as energy released when nucleus is formed from its constituent nucleons. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on binding energy, and then we'll be starting off with a new chapter which is thermodynamics. So till then, good luck and goodbye.